Well, the BC Bank has requirement for between 10 and 18 tellers, depending on the time of day. The lunch time is from noon to 2 p.m. Right, and it's usually heaviest. The table shown below indicate the workers needed at various hours that the bank is open. The bank now employs 12 full-time tellers, but many people are on this roster or available part-time employee. The part-time employee must put in exactly 4 hours a day, but can start anytime between 9 a.m. to 1 p.m. Part-timers are very inexpensive labor pool since no retirement or lunch benefits are provided for them. Full-timers, on the other hand, work from 9 a.m. to 5 p.m. but are allowed 1 hour for lunch. So half of full-timers eat at 11 a.m. and another half at noon. Full-timers just provide 35 hours per week of productive labor hours, and then they have like a table to show us about the time period and the number of tellers required. By corporate policy, the bank limits part-time hours to a maximum of 50% of the day total requirements. Part-timers earn $8 per hour, or we can say $32 per day on average, and full-timer earns $100 per day in salary and benefits on average. The bank would like to set a schedule that would minimize its total personnel cost. It will release one or more of its full-time tellers if it is profitable to do so. Determine the programming for this problem. Okay, so please take your time a little bit and I will show you about the solution. This kind of problem is can help you for the case study, I think. Of course, about the labor planning.
Normally we have prepared so yeah. Okay. Oh. And in the hospital. Oh. Oh. We can do it. Yeah, so next week Sunday to go. One for first hand, another one for second hand. No more than.
Okay, you have come to talk with me about the presentation. So we're gonna have two groups for making the presentation, right? The first group for the first case, right? And another group for the second case. So two cases for next week. The time for making the presentation, please do not use more than 15 minutes because you only submit right that in the course view at that time. So I have to find to look over. So when you make a presentation, just not make it long, okay? And which group that you're gonna make a presentation? I don't know. Did you setting the name 1, 2, 3, 4, 5, 6? What? No. No.
One sec.
The case gonna, if you have the hard one, another week's gonna have the soft one.
Should just be.
Yeah.
Should just be random.
Yes, random. Yeah, let's see. Okay.
ไม่กรอบนะ ไม่เป็นไรครับ
Never mind. Present first is better, believe me. How you can have time to do project. Just kidding. Case that we use in the class is not come from the Harvard case because the Harvard case is probably too long for the course and it requires others knowledge of the field such as operation or the scouting. So I decided to using the case from several textbooks for you guys. Okay, just 3 or 4 minutes and then we show the solution. Okay, this can help you about the second case, the Chase Manhattan Bank. It's quite the same, I think. It's about the planning, about the labor.
Let's go through the greatest up. What's the last?
Okay, how many decent rebels? Okay. 6, yes. Okay. So the problem is about you already have like a full-time worker, right? The part-time. But we want to know that how many of them, right, that we're gonna assign to this dealing with this working time of the bank. So we have 6 different variables. The first one, let's say that I use as a F to be a number of full time that we're gonna assign to this teller, to the full time teller, and another one P1 should be a number of part-time teller that started at there, or can say that they're gonna leaving at 1 p.m. Right? Because part-time work 4 hours, but full-time work for whole day. Right? So So, so that's part-time. We're gonna have the first set is P1, who start working at 9 a.m. and finish at 1 p.m. The second set of part-time is P2 and start at 10 a.m. Yes, for sure, leaving at 2 p.m. P3 probably the number of part-time bank teller that start at 11 a.m. and leaving at 3 p.m. P4 again part-time start at noon and leaving at 4 p.m. And the last one P5 part-time who start at 1 p.m. and leaving at 5 p.m. So the bank would like to setting up a schedule that minimize the total personnel cost. So in this case, even though they have full-time and part-time, but each of them have a different cost, right? So then we need to combine it as the total personnel cost, and we want to minimize. So the objective function is minimize the total daily, right, personnel cost. So in this case, we can see full-time is earns $100 per day, right? And we have what? See, because we have F full-time, right? So that's why we have 100 F. F may be not equal to 12 because it said that we can release one or more, right? Because they would like to save the cost. Okay, so the cost of full-time is 100 F. 100 is per one full-time. We have F full-time that we're gonna schedule to work in this. And how about part-time? Part-time earns $8 per hour or working 4 hours, so then 32 per day. So then we have 32. And we have number of part-time to be P1 plus P2 plus P3 plus P4 plus P5. Right? Because of them working 4 hours and earns $8 per hour. So $32 per day for each of them for part-time. How about constraint in this problem? For constraint. For constraint, please keep in mind that the problem of labor planning when you try to do the schedule, right? The constraint, most of the constraint is about you need to meet the requirement of the total number of staff or people that going to work in that period. So in this case, we look at the table, right? We have 8 period, and we have the number of tellers that we require. Right? So we need to fulfill that requirement. Normally, we're gonna start in this case with the very early time at 9 a.m. During the time period 9 a.m. to 10 a.m. So for sure, 9 to 10, we're gonna have full-time working, right? Let's say if we have full-time to start working at 9. And also P1, right? So if we have full-time and we have part-time start at 9, probably P1. So they combine together, we need to have at least 10 number of tellers required. It is not equal to 10 because it requires 10 that we can use more. But even though the objective function is trying to minimize the cost, but it can happen that we're using the total number of staff more than the required. let's imagine that when you go to the commercial bank at the counter, maybe we need 3, but if you have 4, it's just 5. So the first time period, we have full time plus P1 greater or equal to 10. How about the second time period, full time still working, right? Because full time working for whole days. P1 still working as well because for each part time they work 4 hours. And then we have P2 start work at 10 a.m. Then it needs to greater or equal than 12. For the third time period, 11 a.m. We still have full time, but don't forget that at the beginning of the problem, it said that half of the full time they're gonna have lunch at 11 a.m. So then full time we have remaining 0.5 F. Okay, we still have P1. We still have P2. And we have P3 starting at 11 a.m. And we need to meet 14 as a requirement. At noon, another 0.5 because half of them of the full time have lunch at 11 a.m. and another half have lunch at noon. P1 still working, but should be the last hour for them. P2, P3, and we also have P4 starting. And we need to meet the requirement 16 tell us. At 1 p.m., what happened? We have full-time work. But we have no P1 anymore because P1 is finished. They work 4 hours already. We still have P2. We still have P3. We have P4 and we have P5 start working. And we need to meet the requirement 18. Okay, 18. At 2 p.m., full-time working, P2 finished, so we have P3, we have P4, we have P5, and we need to meet the requirement 17. Okay, at 3 p.m., we have full-time, P4, P5, and we need at least 15 bank teller, and at 4 p.m., we have full time and P5 need to be greater or equal to 10. So this is a basic constraint for labor planning that for each time period we need to have the schedule the staff that fulfill the requirement of total labor that required. What next? We still have the remaining constraint. The next one is what? Since we need to select full time, right? So F cannot more than 12 because they're not all full time. Maybe that we're gonna schedule to be do the bank teller because it's very expensive. So maybe we use just maybe 9, so 3 we just release it. And how about the next constraint? This constraint is quite a little bit I need to clarify for you. If you look at the last paragraph, it said that by the corporate policy, the bank limits part-time hour to a maximum of 50% of the day's total requirement. Okay? Remember constraint, normally we have left-hand side and the right-hand side, right? So both have to have the same unit, right? This is hour, another one need to be hours, something like that. So in this case, look at the policy. Limit part-time hour to a maximum of 50% of daily total requirement. So part-time hour, total part-time hour working actually is each of part-time working 4 hours, right? We have P1, we have P1, we have P2, we have P3, we have P4, we have P5, right? Each of them, right, working 4 hours. So this is amount of the part-time hours, and its maximum just 50%. 50% is 0.5, right? Of the day total requirement. So what is the day total requirement? What is it? Should be what? Because this one is total hour for part-time, right? So the right hand side needs to be hour as well. So what we have here is that if you look at this, the first time period 9 a.m. to 10 a.m. we have 1 hour, right? We have 1 hour, and we need 10 tellers. So total time that we need for the first 1 hour is 10 hours, right? Right? So the second time period is 1 hour as well, from 10 to 11. We need 12 tellers. So in total, for the second time period, we need 12 hours, right? Right. So this is what it means, the total requirement for each day.
Quite clear now.
Each time period is 1 hour. We just multiply with number of tellers. So then we have the total hour required, right, for each day. Okay. So then in this case, you're gonna have like the 10 plus 12 plus 14 plus 16 plus 18 plus 17 plus 15 plus 10. And all this need to be together equal to 0. Okay? Left hand side is hour, so the right hand side should be hour as well. So the total requirement, the number of total hour required for each day, that we know each time period is just 1 hour. We have the number of tellers, so we just multiply, we know about the total time that required for each time period, and then we sum up. So this is the level plannings. Another one is quite the same, right? So I'm going to another example. We go back to the PowerPoint slide. Another example is about the marketing research example. Marketing research example. Okay. The example is about the Management Science Associate or MSA. This is the marketing and computer research firm based in Washington DC that handles the consumer survey. One of its clients is a national press service that politically conducts a political polls on issue of widespread interest. And in a survey for a press service, the MSA determined that it must fulfill several requirements in order to draw a statistically valid conclusion on the sensitive issue of the new American law. So this is the requirement that the company needs to fulfill, right, when they do the questionnaire survey. First one is about the survey at least 2,200 US households in total. Right. Second one, survey at least 1,000 households whose heads are 30 years of age or younger. And for third one is at least 600 for age 31 to 50. And the fourth one ensure that at least 15% of those surveyed that live in a state that border on Mexico. And the last one ensure that no more than 20% of those surveyed who are 50 years of age or over live in state that border on Mexico. So the survey should be conducted in person. And when the company try to do the marketing survey or marketing research, they're going to have the cost. So this is a cost that they have, right, from range of age 30 or less and 31 to 50 and more than 50. We also don't have like the regions of the state bordering Mexico and not bordering Mexico. Okay. The goal is to meet the 5 sampling requirements, this one, and for sure they want the minimum possible cost. So, just 5 minutes to do. Let's do this. Probably the last one for us. This is we use a lot for marketing in the case of the marketing research. Basically. This one should be, I think, change to this one. Must be greater 50, right? So it's not that difficult because the cost per person is also tell us about the region variable already. Right. We have the regions, state bordering Mexico and not bordering Mexico, and also we have the 3 different range of pH. Okay, and we just need to meet these 5 requirements. Okay. So then we want to do that. Okay, how many decent variable? Yes, 6 for sure. So x1 is about the number of person survey. Who's it? Less than equal to 30 and live in state for living Mexico. So x2 is going to be the same, but the S is range from 31 to 50. x3 is 8, more than 50. And for x4 is less than equal to 30, but live in state, not for Mexico. So x5 is quite the same, 31 to 50. X6 is the more than 50. But living the state that not bordering Mexico. So, objective function. So for the objective function, yes, we try to minimize, right, the total cost. Is equal to what? In this case, so we have 7.5 x1 plus 6.8 x2 plus 5.5 x3 plus 6.9 x4 plus 7.25 x5 and the last one 6.1 x6. So how about the constraint? Firstly, survey at least 2,300 US households in total. So it means that total persons surveyed need to be more than or equal to 2,300. Right? So then we're going to have x1 plus x2 plus x3 plus x4 plus x5 plus x6 greater or equal to 2,300. Right? This is the first condition that we need to meet. The second one is survey at least 1,000 households whose heads are 30 years of age or younger. So 30 or younger, and there is no specific live in state bordering or not bordering, right? So we can have x1 plus x4 at least is greater or equal to 1,000. And for the third one, so at least 600 households whose heads are between 31 and 50 years old, quite the same, right? Not specific about the borrowing. So 31 to 50 is x2 and x5. We can have x2 plus x5 at least 600. Okay. And how about the last two? Fourth one is ensure that at least 15% of those surveyed live in a state that borders on Mexico. So how can we write out this constraint? Yeah. Uh-huh. Uh-huh. Okay, quite the same. I cannot recognize for the first sentence, but actually x1, right? We can have x1 plus x2 plus x3. So these three variables, if we sum together, what does it mean? It's about the person survey, right? Who are live in the state that born in Mexico, right? And at least 15%. So it means 50% of what? Of total. So that's why we have greater or equal to 0.15 of x1 plus x2 plus x3 plus x4 plus x5 plus x6. Okay. So this is the amount of the person surveyed that live in the state bordering Mexico, at least 15% of the total. And the last one, ensure that no more than 20% of those surveyed who are 51 years of age or over live in a state that borders Mexico. How can we write the last constraint so we can go home? The last one? Yes. Yes, correctly. X3 less than equal to 0.2 of X3 plus X6, correctly. Because what X3 plus X6 is about person surveyed whose age 51 or more, right? But no more than 20% of that, right? Gonna be the one that live in the state of Born Mexico. Yes, correctly. Good job. So then, okay, all right, go home. Okay, so that is, so I think you can getting some idea, right? The case study is have some trick.
Can you tell?
That, no, I cannot tell that. Cannot
Can you tip?
remember actually. And I have mentioned that please do not searching for the solution, so it's not worth without if you can see the solution from the Google, so why do we have to give you as a case study? Because I want you to practice, right? Okay, so next week, okay, next week, alright, okay, next week we're gonna start the new topic. Still within the linear programming, but this is the extension of linear programming. It's like the one application of linear programming. It's about the transportation problem, about the method that we're gonna use for calculate, right? How can we deliver or shipping the product from place to another place with a minimum cost, something like that. Yeah. And enjoy the case study. Okay. Yeah, that's it for today. Thank you for your attention. Okay.
John Cup. The groups are on Courseville. So do you want to assign the groups? I think there's 5 out of 6. Oh, Jay, this cricket is amazing.